Okay. Is my screen visible to you?
Yes, ma'am.
Okay. We saw about what is termite proofing yesterday. Like what is termites, why the termites are attacking, how it is attacking we saw. We'll see how to overcome this termite attack in today's class. Termite proofing. Okay. Termite proofing. Why are we going to do termite proofing? We are in a position to destroy this growth of termites and we have to save our structure because our wooden frames, windows, doors, everything is getting attacked by termites. We have to prevent it. These termites are nothing but the white ants. It's locally called as white ants. Hence, it is necessary to treat the house with termite proofing. We are going to just stop the growth of this termites. So types of termites, we have two different types. One is ground nesting termites and another is dry wood termites. Ground nesting termites are nothing but it is based upon like you have the soil surface here. It grows, it lives within the soil itself. It will be everywhere here. If you start your foundation work or something, it will start generating, it will grow from your structure. It will, I mean, your entire structure, you can see the spread of ground nesting termites. These are basically subterranean type. These termites maintain connection with the soil. Adequate moisture is required for their presence. If little dampness is observed, then they'll start growing. They feed on woods and other cellulosic materials like papers, cardboards, and clothes. Dry wood termites, nothing but non-subterranean particles, like they are this category where it live on wood only. You might have seen some large olden trees where they'll have some small ants. It will be always like it will be moving here and there. Have you ever seen in your schools or your colleges whenever you're crossing? Might be you try to notice or any public parks if you go. If it is a little wider and older tree, if you just go and you scratch it, you will find so much of insects over there. Those are nothing but the dry wood termites. They live basically on the woods. They need some moisture or that humidity that will help them to grow. There are three types of termites, that is chloroferosis concentrate, that is 1% by the weight, heptachloroconcentrate, chloridane concentrate. These are the three different types of termite proofing material that are applicable for dry wood termites. And you have a certain list of chemicals with their concentrations. These are the allowable limit of concentrations as suggested by the Indian standards. This type of concentration you can mix it with water and you can utilize in your work site. Maybe not only in your work site, if you find any termites anywhere, or I told you know, like if you find any that wound type of or the heaps of termites, you can just eradicate it. These are the different types of chemicals. I'll let you know the code number so that you can even go and search for the IS code and you can find more details about it. The maximum content is DDT, which is it is nothing but organochlorine insecticide. The all the chemicals here are mainly insecticides. The major thing is up to this four things, five things. All these chemicals, it has a base of organochlorine insecticide only. So all these are utilized in the worksite to eradicate. If you have so much of uncontrollable growth of termites are there, then you go for DDT. If you have only moderate, then you prefer to go for this four categories: BHC, aldrin, heptachlor, and chlorodane. This is the IS code book. IS 6313 part 1 and 2, where you will find treatment procedure, detailed treatment procedure for this termite proofing will be given there. You can have a glance and we'll see about this. Pre-construction treatment. What are the pre-construction treatment that we are going to follow in the work site? So before constructing a structure, how we are going to prevent from the termites? should start during the construction is carried out, right from the time when you are laying the foundation itself. You should be aware that you should go for this termite proofing. Okay, so I'll tell you the simple thing. You are first going to dig soil. You'll be digging the soil for laying a foundation, right? That time itself, after digging, you have to spray the coats of termite proofing materials, maybe your insecticides or your organochlorine chemicals that you're going to spray. Once you're done with it, again you're going to backfill with soil. Up to this, you'll be filling with soil. Again, you're going to spray. The thing is, if you have a box here, if you spray here in this surface, here is your foundation going to start. So again, one layer is done. Again, you fill it up with soil. Again, you have to treat it with the insecticides. Again, you'll be backfilling here the third layer. Over that, you have to give the treatment for this insecticides. And again, you'll be laying the foundation. Once the foundation is done, you'll be having soils here to backfill. Here you are going to fill it along the sides of the foundation. There also you are going to treat it. The concept is throughout the enclosing this entire area, you are going to treat it with the insecticides, because you have your foundation here. You will be having your layer of floors, your wooden layer, as well as your you'll be having your door, windows, all those. It is interconnected, so the growth is highly possible. You are going to reduce or minimize the possibility for this growth. Okay, 1 minute. Just hold on for a second. Okay. Okay. Now, soils can be, the first thing we are going to do is we are going to clear the soil. The waste particles or the debris, you are going to clear it. On clays and other heavy soil, where the penetration is slow, and on sloping sites, where runoff of the treatment solution will occur. Like if you pour, if the surface is if it is in a hilly region, if you excavate soil, if you are pouring in the surface, if it is sliding away, that should be taken care. So the surface of the soil should be scarified to a depth of, that is, you have to dig at least a depth of 75 mm. On loose, sandy or porous soil, the loss of treating solution will occur through piping or excessive percolation. Preliminary moisturing to the capillary spaces in the soil is recommended. Borrowed soil, that like once you are started digging the soil, then you have to make sure that it is free from the organic debris, and it should be well compacted. The initial thing is you dig the soil, you will again compact it, because when you are digging soil, like you have the soil here, you are digging it throughout. Again, you'll compact it, because this soil, already existing soil, will be very loose. Now we are going to compact it. Once it is compacted only, you can place your structure there. Then, okay, this is done. Then form work, all form work, leveling pegs, timbers and other builders debris should be removed from the area. Like when you're going to treat this particular area, any debris or any other disturbances present there should be removed. Okay. And chemicals and rate of applications for the mount treatment. This is called the mount treatment. Have you seen this type of mounts everywhere? Maybe in your any parks or somewhere in your colleges or somewhere where there is open area. The thing is, where there is the people access is very less. Now you'll be able to find it. If you see somewhere in the road, no, like our people will start digging it, they'll completely spoil it. So that where man access is very less, only in that region it will be more. If mounds are present, should be break open and treated with insecticides. It should be completely, you should cut it and then you have to treat it. Only then you have to remove it. If you remove this alone completely, then you will have this continuity or the chain growth embedded in the soil. That also you should stop. So you have to cut it, treat it, again remove this. You have to remove the second layer. You have to treat it and then you have to dig this completely and you have to remove it. The quantity to be used will depend on the size of the mound. For a mound volume of about 1 meter cube, if the volume is about 1 meter cube, we are in a position to spray 4 liters of emulsion. That is 4 lit. I mean, this all any of these three, you are going to take it for 4 liters of water. You are going to take 0.2 percentage of aldrin or heptachlor or chloridine. All this you are going to use. Next
Ma'am,
is
one
soil
small
risk.
doubt.
Yeah.
Ma'am, we are using these chemicals for killing them or just as repellents?
No, you're for killing it.
Okay.
Once you're killing it, now it will not grow also. Then its chain of growth will be cut. Then it will not grow.
Okay, ma'am.
Soil treatment, preventive measure to create a chemical barrier. Like this is the initial step. Before laying your foundation, you will dig the soil. No, that time itself you will give a spray coat over it. Using your either sprayers or your pressure guns, you will give first chemical attack. It is like based upon the soil only how much of quantity growth will be determined. So you are going to spray it. Then following chemicals and water emulsion is effective when applied uniformly over the area to be treated. We should make sure we are covering the entire surface. Not only at the bottom, we should be aware that we are spraying it along the sides also. Okay, because the sides also like it is surrounding your structure. You place your foundation here, you have this sides exposed to your structure. Aldrin emulsifiable concentration is 0.5 percentage. Heptachlorine is the same 0.5 percentage. Chloridine is 1 percentage by weight of water. If you're taking 1 liter of water, then consider you have to take only 0.1 percentage of that chemical. Then pre-construction treatment. Now how we are going to treat it before construction stage. Any termite mound found in the site should be sprayed with the chemicals. For masonry, basement and foundations, that we'll be seeing now. For that, bottom and side of the trenches up to a minimum should be excavated. Now we are going to excavate it. For a minimum of 300 mm from the bottom, and it should be treated with 5 liters. That from here you are going to excavate 300 mm. You are going to spray it, provided you have to spray concentrate with the concentration of 5 liters. You are going to spray it. If it is going to be per meter squared area, you are going to take 5 liters. All refilled earth in contact with the structure should be treated with a rate of 7.5 liters per. Once it is sprayed, then you are going to again refill it. As I told you, once you are refilling one layer, you will be taking about 7.5 liters and you are going to spray it. This will be sprayed both on the sides as well as at the bottom. If the water is used for ramping the earth fill, then a chemical treatment shall be carried out after ramping operation. Is provided by rodding the earth up to, okay, I will tell you this in detail. Initially, you will be you will be digging the soil, you will be done backfilling it, you will be backfilling it. Then again, you lay your foundation. Once your foundation is done, you will be going for the laying of plinth level. Before that, you have gap here. There you will be filling the sand. Initially, you will collect all the soil nearby and you will dump it. Then you will be compacting it. Once compaction is done, then you will go by watering it. That you have to make sure you pass water to it and compact it very tightly. Once it is done, over that you will be using your gravels, 40 gravels. Over that you will be going your cement mortars. Then only you will be placing your cement mortars will be done. Finally your cement slurry will be done. Over that only you will place your either your carpet materials, that may be your brick your mosaic or your marbles or your tiles. In this area, when you are watering also, like once you are dumping with the soil, again when you are going to water it, that time you should be careful that you are going to create this. Imagine this is a top view. This is a soil compacted with water. Then you're going to create a grid-like structure of a 150 mm. Like this, you are going to create a grid-like structure where you are going to insert the sprayer and you are going to spray it. Make sure that the soil doesn't develop the growth of those insects. Then that's all. This is about the procedure. The chemical emulsions shall be directed towards the masonry surfaces. So the earth in contact with these surface is well treated with the chemicals. I'll tell you. This black color coating is there. No, that is nothing but where we are doing our spraying, where we are treating our surface. We are treating it throughout. The base you are treating and the side you are treating, as well as your size of the structure, that is your foundation. Either it may be a step foundation or a sloped foundation, but we have to just provide this treatment throughout the foundation. And this is plinth level. Over the plinth level, I told you, this is the plinth level. You compact it with the soil. I mean, you fill it with the soil, you compact it. Then this is the sand bed over it. Again, for this, you are going to drill 150 mm. Like I told you, spacing should be minimum 150 mm. You are going to drill and provide this coating. This one you can provide, this treatment can be done directly, whereas in this case, after land filling only, like you have to drill holes, or like if it is wet soil, if you just insert your spray will be into it, then you can spray it. Okay, this is okay. Here, this structure is without an apron. Apron is nothing but the external cover that you provide. Here you can see this is the presence of apron. That is a concrete layer you provide in order that this area of access is, it will prevent the growth of access. But here it is open. So this type of open without apron, it may lead to the penetration of termites on the outer surfaces. For RCC basement and foundation, the concrete is dense. We know huge structure. We have foundations. The termite are unable to penetrate it. I mean, it is unable to penetrating inside. Hence, the treatment shall start with the depth of 500 mm below the ground level. As we initially saw, the depth should be minimum 500 mm. If ground level is raised or lowered by filling or cutting after the foundation has been cast, then a depth of 500 mm shall be determined for the new soil level. Again, like if it is done, either if you didn't treat or you have raised the surface, that is, you initially cast a foundation here, you plan the floor to be here, but now you have seen, like maybe in your, as per your locality requirement, might be your roads are very higher than your house, I mean the planned house, so you can lift it, you can lift your floor. That time you have to go for again compaction. That region, like only this is done, so again you have to excavate soil for 500 mm, you have to spray this area, and the same process of your plinth, your sand, those things has to be carried out. And soil in immediate contact with the vertical surfaces of the RCC foundations, it shall be treated. Vertical contact is this. Told you are providing. Sorry, if you are 1 minute. This is your foundation. This is the vertical contact, whereas this is the horizontal contact. This vertical contact, this should be treated with 7.5 liters per meter square. You see, this is our RCC foundation. We have provided the base coat. Through the sides, the horizontal and the vertical member, we are going to provide this, insecticide treatments. Treatment of top surface of plinth filling. I told you, once it is done, you are going to do this in a grid manner. Actually, it should be in a grid manner. You see, this is a grid manner with 150 mm spacing. If you just spray the chemical into this, it will be spreading uniformly. It will be cutting the chain growth. If there is any chain growth, it will be cutting it. 5 liters of water should be, always remember, for the horizontal member or the horizontal spray, we require only 5 liters. For the vertical spray, we require 7.5 liters per meter square. Treatment of junction at the wall and the floor. Continuity of vertical chemical barrier on the inner wall surface from the ground level, it should be ensured always. because it generally comes from the inner wall. You have your plinth level here. You have compacted it with the soil. Should make sure that then you have your floor here. Sorry, you have your floor here. Over that you have your wall or your door. Imagine this is your door. Cut, this is your door. So this is very tiny layer that you have only your cement slurry and your top tiles or your marbles. This, it should not grow through this. You should always make sure, or once you are done with this, you have your wall and you have your floor. You can just create a channel that is C type, like open type. You can just create it. That is 30 mm cross 30 mm. You can create it. You can treat it throughout your structure. Imagine this is your wall. Create a channel of 30 mm here. You can treat it with the termite proofing coating or the chemicals. Once you are done with it, then it will not penetrate, or then you will not find any termite access there in your building. Chemical emulsion is poured along the channel at the rate of 7.5 meter square, the same for the vertical wall or the column surface, so as to soak the soil right at the bottom. This is done along the external side. I told you, no, channel type. This channel type can be done in the internal also. It is based upon the soil. If you find so much of mounds near your soil or your work site, then it is better to go for an internal wall coating also like this. This is along your outside. This outside, like doing outside is very good because you have so much of soil exposed here. So it is better to give an outer coating in all type of buildings. Treatment of soil along external perimeter of the building. Holes of 300 mm deep, depth, it shall be drilled at 150 mm interval along the external perimeter of the entire building. Chemical emulsion can be, are you all along with me?
Yes, ma'am.
Okay. Chemical emulsion should be poured along the water at the rate of 7.5 liters. This is a constant repeating point, but as we are seeing for every member, once we saw for the foundation, we saw for the floor, now we are seeing for the, external wall. In that case, we have to again follow the same liters, the same square areas, the same units. We have to stick on to it. Expansion joints and periphery of the around the pipes and conduits, it should also be treated with the chemical emulsions. Door and window post. Post is nothing but you will fix a wooden frame to your structure. You'll be having brick walls here. Your brick walls are here. Only the wooden frame you will be fixing it first. That time itself you have to coat it, or you have to spray along the entire wooden frame. At the time of installation itself, you have to do all this coating. Post construction treatment. You are done with the building. Now you want to do your termites. You didn't do any coating or you didn't provide any termite proof while you are constructing the building. Now your structure is constructed. You find some termites there. Now how you are going to overcome it? In case of termite growth in constructed buildings, pressure pumps are utilized. We require pressure pumps because it has already started growing. But in the pre-construction stage, we use only sprayer. Sprayer is quite enough, so you are going to uniformly spread this. That is more sufficient in the pre-construction treatment. Here you require pressure pumps. So the proper penetration of chemicals is required. Outside walls around the building. In case of a flagging concrete is there, holes of dia 12 mm are drilled at a distance. Here, flagging concrete is nothing but don't think it is a special type of concrete. It's not a special type of concrete. The concrete like that, it started getting weakened, or the structure is started deteriorating due to this termite attack. This flagging is nothing but losing its strength, losing its originality, structure. The holes are drilled, 12 mm dia holes are drilled, the distance of 300 mm, close to the wall, and again this pressure pumps are utilized, so the pressure guns are utilized to spray this chemical emulsions. If there is no flagging concrete, 500 mm deep trench is made to expose the foundation. Then 500 mm deep holes are drilled at a distance of 150 mm and the holes are treated. This is soil under floor. To treat the soil under floor, holes of 12 mm dia are drilled at a distance of 300 mm along the wall. Construction joints, cracks wherever required, you're going to do it. Chemical emulsions is pumped at the rate of 1 liter per hole. Like you're going to wet it, you're going to wet the soil. Treatment at the plinth level. Holes are drilled at, we already saw, no, like a grid pattern we saw. Here it will be our holes. We saw this grid pattern. You should make sure that the angle is 45 degrees in case of treatment at the plinth level on both sides of the wall at plinth at a distance of 300 mm from the center. After pumping with chemical admixture, the hole is filled with cement mortar of 1:2 proportion. That's all about termite proofing. Now we'll be moving on to damp proofing. What is damp proofing? Have you seen this type of deterioration in any of your structures in your maybe your olden houses, or you may this type you may observe in your ceilings or near to your bathrooms, even in your hostels or somewhere else? Have you seen this type of spalling of concretes? Have you seen? Okay. Okay, this is nothing but this particular wall or the concrete is getting damped, it is getting wet. Once it is getting wet, this wetness is prevailing for a long time and it is started, this plastering work, it starts peeling off by itself. It is keep on like it is observing so much of moisture, it is starting to just loosen its plaster and its plaster will fall off. You can see first this plaster falls. Then this particular area, the paint falls and the plaster falls. Then this brick wall or the concrete wall, it is being exposed. This is called dampness. How we are going to overcome this? How we are going to proof it? That is, you're going to coat it, or how you are going to prevent this type of dampness in your buildings. Causes of dampness: moisture from the ground. Maybe you might have noticed, like when you're having heavy rains, you can see, I'll show this once again. Have you seen this type along your ceilings? This along the junction of your walls, your roof, near to your windows, all those things happen always. When you're having heavy rain, even this occurs in a newly constructed building. Heavy rain, if you're having heavy flood, all those things, you can observe this type of dampness. This is caused due to the moisture from the ground, splashing of rain, exposed top of the wall, condensation process, and maybe due to construction defects. And if so, it is because of construction defects. We'll see what are the defects. Improper planning of drainage. Do you agree? If you did not provide proper drainage to your structure, will this dampness occur?
Yes, ma'am.
Yes. I'll tell you an example. Imagine this is your terrace roof. Okay.
Yes, ma'am.
The terrace, you will always find one. You can go sit in your terrace and you can just check it whether it is 100% horizontal or it is little slopey. It will be little slopey. Not too much, but they'll provide little slope, because only if they are providing slope, if the water, if it is raining, then this water should be carried away, and there will be a outlet in the parapet wall from which that water will be either collected and carried away to the rainwater harvesting, or it will be drained off from your building. This slope will be always provided. If the slope provided is not proper, you can see like this may not be uniform. Like you can see, this is the water, splashing of water. We'll have this as the water level. Okay, water is getting stagnant here because maybe the outlet may be the top, or some manufacturing defect may be there. Our masons may not be that proper to provide it. Yeah, you consider this. This is the outlet here. You have the water stacking at this level. So what you will do? This water, what it will play a role is, it will start wetting this wall. Yes, you have this parapet wall. This parapet wall, it will start keep on wetting this parapet wall, and that dampness, it will penetrate through the walls. Yes, this is your roof. This may be your room. Consider this as your room. Okay, this dampness you can experience in your internal wall or your external wall also. Yes, do you agree with me? Are you all along with me?
Yes, ma'am.
Yes.
Yes,
Now,
ma'am.
are you able to understand why you are seeing all those dampness in your building? This is one such example of where water is getting stagnated. This same type you can consider maybe your under your water tank or your near your bathroom, so and so. This type of I mean, water is getting logged and it penetrates, and your structure you can see damps everywhere. Okay, dampness is observed everywhere in your structure. Improper planning of drainage, lack of proper slope in roof, defective pipe fittings, improper sealed construction joints. All those leads to dampness in our structure. Your today's task is go search whether there is any dampness in your house. Okay? Only, I mean, maybe inside your house or your outside your house. But don't go outside to the street and just roam here and there and tell, ma'am only told to see dampness. There is no dampness in my house, so I'm going to my friend's house to search dampness. Okay. Yes, say yes or no.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. I think if you people are not interacting with me,
Yes,
it is
ma'am.
better for me. Yeah, thank you. Thank you so much. If you're not interacting with me, it is better for me to give a recorded video for you so that you can see the video and study. Is that okay for you? If you're not interacting with me, then that is going to happen. Yes? Okay.
No, ma'am.
That will be very boring, no?
And this is
Yes,
better,
ma'am.
ma'am.
This is better. Okay, okay. Thank you. Okay, effects of dampness. Dampness weakens the structure and has adverse impact on the health of the inhabitants. You just think your this is your wall. It is experiencing dampness. This area is experiencing dampness. If it is wet, you will have so much of insects and mosquitoes. It will be settling there. It will start generating. It will like start breeding. It will grow. That is going to again affect your health, as well as there will be some musty smell inside your house or a room when you experience this dampness, maybe along your, I mean, throughout the rainy season. Those things happen. I experienced this dampness during the Chennai flood. I experienced this in the 2015. I experienced this in a newly constructed 6 months old building, not in a 6 year old building, a 6 months old building. There was some musty smell. The thing is, outside it is very very bad. Inside it is comparatively good. So with no other go, we were inside this dampness. Okay. Patches over walls and ceilings. Plaster will soften and start crumbling. What is crumbling? Anyone? Anyhow, we are not going to answer, ma'am. It is waste of time for you to like shouting like this, ma'am. You yourself answer, ma'am. That is good for you, ma'am. Yes, I can hear some mind voices like this. Yes. The major disadvantages is on online class. No, like I'm not able to see your face. See your face, and like if I if I request you to turn on your video, my slide sharing screen will be minimized, so you'll not be able to see this screen. That's the reason I'm not able to exactly catch your mind voices. Yes, no, yes or no.
Yes, ma'am.
Okay.
Yes,
Ma'am.
ma'am.
Okay. Crimpling is nothing but breaking or falling apart of the small pieces
Plaster
of the
from the wall.
fragments. Yeah. Plastering. The plastering is going to just break and fall into pieces. Any wall decoration materials used will get affected. If you're going to paint your wall with so much of layers, so much of coatings, finally your painting, everything is done. You have spent 2 lakhs, 3 lakhs for your house or your room. Every coating is done. If it is a rainy season, if you say dampness, how will your heart not break? I have spent this much of amount. I have chosen this from ancient paints. I have got this from so and so painter. I have designed it accordingly, but finally it got damp. Will you not feel?
Yes, ma'am. Definitely it will.
Yeah. So these things, like what are we going to do, or what are we about to see, like how to prevent all this dampness? Disintegration of tiles, stones, and walls due to efflorescence. Woodwork may start to decay. Dry rot or fungal infection. This may, like fungal infection will be there definitely if it is wet. No, you will feel some fungals or algae will start developing from the wetness. Corrosion of metal components, electrical fittings get damaged. Yes, you might see in olden buildings or in olden mansions, or there'll be like huge structure. If one floor is getting damped, everything will be not concealed wiring. It will be outer wirings where it will get damped, and the possibilities of shock is there, high there. Results in breeding of mosquitoes, growth of termites, and several health issues to inhabitants. Like people who are residing there, health issues will definitely be there. Requirements of materials used as dam proofing. Okay, should be impervious. That is, it should not penetrate. It should be durable with longer lifespan. So, the dam proofing material, it should be impervious and it should be very durable, capable of bearing the load imposed on them. Like we are not going to put so much of load, but even though it should bear, it should not peel off or it should not break into pieces. We should make sure that the material is little load bearing, flexible enough to accommodate the structural movements without any fracture. Maybe that may be a roll or a sheet type, that if your person is keep on walking, a weight person, a bulky person is keep on walking, it should not like experience any fracture, or it should not break, or the continuity should not break. Should make sure that you provide a better load bearing and fracture resistant material there. Should be free from sulfates, chlorides, and nitrates. Materials used for dam proofing, we'll see what are the materials used. The main materials are hot bitumen and mastic asphalt. Hot bitumen. You know what is bitumen? Have you seen people laying bituminous road? They'll call it as tar. It will be sticky, dark black color sticky like material. That like it will be a rubber type material. Once if you heat only, it will get stick to, I mean get stuck to your material. Hot bitumen 3 mm thick may be applied on the mortar. Once your mortar is laid, over that you are providing this hot bitumen. Mastic asphalt, semi-rigid material. By heating asphalt along with hot asphalt mixed with sand and mineral fillers. Mineral fillers may be your fly ash or your any industrial waste products. When you are mixing with it, that can be applied over the cement mortar or the cement bed. Impervious and it is highly durable. But in very hot weather or under very heavy pressure, it may squeeze out also. Bituminous felt. What is bituminous felt? It is available in rolls. As I told you, it will be sheet like layer. You can just unroll it and you can place it over the flat mortar with the finished surfaces. An overlap of 100 mm is provided at the joints. Wherever it is joining, no, that area alone you are going to provide an consecutive layer. Like you're going to just provide in the zigzag manner, you'll be providing for 100 mm. Should make sure that through the joints you should not penetrate. Metal sheets. Sheets of lead, copper, aluminium can be utilized. Lead is the highly durable or the highly preferable material. These sheets, it should be protected with a layer of bitumen. Whatever you do, you protect it with a coat of bitumen. Combination of sheets and felts. Sandwiching a lead sheet. Once you place a lead sheet, over that you give your bituminous felt. Then it is done. This is impermeable. This is also impermeable. When you coat both, it is going to be highly impermeable. Plastic sheets. the thickness of 0.5 to 1 mm thick plastic sheets are utilized. That will be a black polythene sheets. Don't think a normal polythene sheets. You have a special type of polythene plastic sheets for this damp coating. Cheap and a permanent method. This is a very good solution where it will not allow your water to pass through this material. Bricks of good quality whose water absorption is less than 4.5 percentage of their weight can be also utilized. These bricks are laid in 2 to 4 courses in cement mortar. You remember your horizontal layer is called the course. You provide, this is your course. Do you remember or you forgot?
Yes, ma'am.
Okay, this is called the course. You provide 2 layers and you put your cement mortar. Again, you provide either 2 layers, put your cement mortar, or you can take it to 3 or 4 also. Next is the method of dam proofing. Now we are going to see in the foundation. For the foundation, what you are going to do is an air drain of 200 to 300 mm is constructed parallel to the wall. The drain is covered with RCC slab and gratings are provided at rectangular intervals. Vertical and horizontal dam proof courses are provided. If it is going to be your foundation, you should make sure like a parallelly constructed air drain is there through which water will not penetrate. You are going to cover it with a RCC slab. For the treatment of floors, if the soil is not damp, consider if your soil is not damp, a layer of coarse sand. Coarse sand is the a bigger sand. Fine sand is going to be this. Coarse sand is going to be maybe a spherical shape, or if it is going to be M sand, then it is going to be crystal shape. The shape may differ. Coarse sand of about 75 to 100 mm thick is provided over the entire area of flooring. Then cement of, then the ratio of 1 is to 4 is to 8. That is, cement is to fine aggregate is to coarse aggregate. Cement, sand, your coarse aggregate. This ratio, if you're taking for 100 mm thick, that is that you're going to lay it as the damp proof course. They'll say, I'm going to lay 100 mm DPC. They call this damp proof course as DPC. They'll follow this ratio only in IS standards. 1 is to 4 is to 8 for height of 100 mm. If the soil is wet, a member of DPC is provided over the floor area over which a layer of flat bricks is laid. Usual flooring is then provided. After this DPC layer, you are going to provide a brick layer. I'll tell you where the first point and the second point is practically applicable. This is your first thing. Here, we saw about you'll be filling it with soil, compacted, again sand layer, sand blinding. Over that, this blue color indicates your damp proof course. This blue color. So this is coated along your vertical. See, vertical also it is coated, along your horizontal also it is coated. Over that you have your concrete. And how you do this treatment, how you provide, this is along your foundation. Remember, this is along your foundation, you provide like this. You provide like this. When it comes to your roofs, what you do? Should we provide damp proof course in the roofs also? What is the necessity to provide damp proof course in the roofs? Answer, anyone? Anyone? Okay.
To restrict the seepage of water after rain.
Yeah, definitely. That's the reason. See, this is your concrete floor. Here at the bottom you have your ceiling. Just look at the top. You'll be having your ceiling. That ceiling, like the bottom surface of the ceiling, it may be either rough or smooth. If it is going to be rough, that is your concrete surface. You have just painted it. If you are having a smooth finish, which means you have given a plaster over the rough surface and you have painted it outskirts here, this area. Over that you have your concrete RCC slab. This is your concrete slab. Over this concrete slab you have a black color line. Black color line which indicates that is the damp proof, that is the DPC code there. Okay, this is the DPC coat. That is, it is made up of hot bitumen paint. You're coating it of about 100 mm. Once it is done, then you are moving on with the mud pashka, which is nothing but this. They'll call it as brick bat jelly in South India. This type of bricks they'll break and they'll place it continuously along over the DPC. Okay. Over that, this is the DPC. Sorry, this is the brick bat jelly. Over this, they'll finally fill some soil over it. Finally, they'll coat it with a cement slurry and then they'll place this final bricks. Bricks or the red color tiles will be in there in your terrace, right? Red colored mud tiles will be there in your terrace. Whenever you are free, you can go and check it. Or in few houses, it will be just a concrete flooring. You can go check it. That will be there. And this is nothing but the gola. They will call it as the side covers. Like it will not be very flat. This parapet wall. This is called the parapet wall, which means a wall which is preventing you from fall. This wall. Have you seen this wall?
Yes, ma'am.
Okay, this wall is called the parapet wall, but this is a joining between this parapet wall and this because like it is either provided in this manner or it is provided in a curvature manner because this water it should not get lagged there, it should just flow off so that they are provided it in a slopey or a curvature manner. That's all. That's all about dam proofing. Okay, let me stop share my screen.